Hi, I'm Mike Monroe. Tonight I want to share a case study for some work we did for a client a few years back. And I'm going to start filming some of these videos, sharing some stories for some work we've done, really as a means of trying to help out some other companies out there. Maybe these companies might see some problems that I describe and some of the solutions that we've provided. And hopefully they can get some ideas of either better understanding some of the issues that they have today, and really trying to understand some of the options they might have available to deal with some of the issues they might be running into. So so where does this story begin? It's a global financial services company. They had a product that was doing about 18 million in revenue a year, with users measured in the thousands. Sorry, let's get another zero in there. So not a tremendously huge product in terms of user support and even in load on their application, and we'll talk a little bit about that. They reached out to us because they had it was a legacy application that was built before we started working on it. It probably hadn't had much technology investment in 10 to 15 years. So predominantly they had a web-based application built with Java and a set of Oracle databases. They had clients around the world, so they would have their usage patterns where they'd get busy as New York came online. They would get busy as New York was kind of closing in terms of financial markets. London open and close, and then Asia open and close. Those are their peak periods. Usually, an hour and a half to 2 hours, kind of as markets opened in an hour and a half to 2 hours before markets closed. Definitely some regular usage in between the opens and close, but those are the peak times. But even in those instances, peak usage was, hundreds of users on the system at a time. So in terms of what web applications can support, the load was fairly minimal. So what were the goals when they reached out to us? It was really two big things. One, modernize their current app. We'll talk a little bit about what I mean by modernize. And they wanted to move to the cloud. And we'll talk about that as well. Okay, so modernize their current app. Why was that? The application before we started working for them probably hadn't seen much heavy investment in terms of new feature development in 10 to 15 years. So as I stated earlier, it was a Java-based web app. And when it was built, I think if you were to go back to the time that they built this app, it was probably actually the technology choices were probably the right choices to make at the time. The design aesthetics that they utilized probably looked pretty good at the time. But you fast forward 15 years, and all of a sudden you start comparing this to more modern applications, not just the look and feel, but also how they were built. Weighing the options available for the new technology stacks from a web application perspective, and it was just what they had was completely antiquated. So let's also talk about now. Let's talk next about their move to the cloud. Okay, so why was this also very important to them? Well, I mentioned earlier. Offices, New York City, London, Asia. They also had server rooms. I don't want to say sizable server rooms, but in New York City, server room. Now, I think it's important to remember, I'm saying server room. They didn't have servers in a data center. In their New York City office, they had think of an office space inside of their larger office that was converted into a server room. Typical HVAC, other things you would do to manage a room full of servers to make sure that they're running at the right temperature. It's cold when it needs to be. Just a lot of overhead and a decent amount of servers. In both instances, obviously we're not talking about data center size, but in both places, there's probably 10 to 12 actual physical servers. And one of them in New York City, in their New York City office, was an EMC vBlock server. This server was installed probably, it was about a year before we engaged with the client to kind of understand their infrastructure or their application and help them provide some strategy on how we would rebuild this. This vBlock server, when we looked at some of their previous operational costs, about a year earlier, $750K spent to purchase the server itself and to have it installed. This is just one server, $750K. Let me remind you, thousands of users. That's not a lot for a web application when we took this over. There's absolutely no need for a server of this size. It's crazy to a certain extent. But they had 10 to 12 other servers. Their plan at the time was to stay with on-premise servers. I think there was a lot of other options to be a little bit more resourceful with spending in this instance, but it is what it is. I think you'll get to see the cost savings we provided when we rebuilt our application and moved them onto AWS. It was a tremendous change. So let's talk about their app again. Let's talk about the database on their app. The database for their apps that they had were 1+ terabyte. Now, when I say database, it actually wasn't the database itself. When we first started doing due diligence with the current operations team that supported this, they were really just reporting back disk size. And why does that matter? Because as we found out later on, you'll see how small the production database was after we rebuilt the product. Dramatically smaller. Really what they were doing is this 1 terabyte was also accounting for years and years of backups of backups of backups, and really they're just storing it all in the same place. So initially they reported back database 1+ terabyte, but you'll see when we talk about it later, the database ended up being tremendously smaller. So let's go back to the servers again though. I mentioned earlier, server room in London. Well, the managing director that we were dealing with on this product, they wanted to move the office in London, and that was presenting a problem. Their resources changed dramatically in London. Sales, even some of their marketing resources were starting to not be in the office as much as they had been previously. The company wanted to move to actually a nicer office with better lease objectives. And they had this office in London with a server room, and the expenses tied to moving these servers from one location to another were becoming cost prohibitive. And at the time we engaged with this client, AWS was already in use by a tremendous amount of companies out there who were moving away from on-premise infrastructure and into AWS. So it seemed like a no-brainer, and we'll talk a little bit about what they ended with. So there's a couple problems here, right? We've talked about a legacy application built in Java. Some overhead of data being carried around, tied to a database. Server rooms, New York City, London, a lot of overhead. Their operations teams to support these server rooms, ops team, not dev team, just ops team, 6 to 8 people. Dev team was 3, QA was 1 to 2. A sizable team for supporting just a web application. Granted, it's global usage, clients around the world who are logging in use this thing. But at the end of the day, it's still thousands of users, and at peak usage, concurrently, you could measure it in the hundreds of users coming on at the same time. Very manageable in terms of compute utilization, especially for what the product was doing. The product, and I wish I had brought this up earlier, but the short of it was the product was delivering data and analysis for institutional fixed income asset managers. So think credit, information, rates, information. And this was not just data, but also analysis. The company had people internally who were watching the markets and writing up commentary, and then also looking at data and charts and providing that. And the product pulled in data from some third parties and presented it in a meaningful way for these institutional fixed income asset managers to make better decisions in the portfolios that they were managing day to day. So let's talk a little bit more about some more expenses that they had in there before. This was in front of an Oracle database. This database and the support of the database and the machines that they were running these databases on were running them about $225K per year in licensing and support costs. And this was basically an ongoing contract. I think when we came on board, it was renewing. They were coming up on a 3-year renewal, I believe. And so part of this process was to rebuild their product, to not just get them into the cloud, but also hopefully move them away from this type of support engagement that they're required. We talked a little bit earlier about their 6 to 8 operations people. The operations people would obviously, if there were any major issues with the database, could reach out to Oracle. But this is a hefty price. I think the company was doing great from a revenue perspective, but the margins could be much better. A web application just doesn't require this type of overhead. So anything else that I should touch on? No, I think that's good. So we did a little bit about what the before looks like. Now, let me tell you what a little bit of the after looks like. So we went and we started this project with an assessment of the product that they had, the product that was built, the team that was working on it, the types of skills that the team had, what type of technologies we thought would be best suited for them moving forward. And so the prescription for them, when we started this project, and we provided some upfront strategy in terms of what they have and where we thought they should be. And then we provided them a roadmap of how to get from point A to point B. And so what was the prescription? Well, we prescribed for them a Ruby on Rails API with a JavaScript-based front end. And so and then let's talk about the database as well. Plus Postgres database, open source. So already we're gonna save a bunch of money. So let's pause here for a second. So Ruby on Rails. This is we do a tremendous amount of work with Ruby on Rails. For us, this is bread and butter. This is in our DNA. One of the benefits of utilizing Ruby on Rails is the convention over configuration. And so when we bring developers on board, especially if they're new to the team, if they've worked in Ruby before, it's very easy to get them up to speed. With the conventions in Ruby on Rails, you do a good job following those conventions. Developers come on board and they can ramp right up. Obviously, they don't need to ramp up on the technology stack, but for sure, you can just focus on getting them up to speed in the domain knowledge of the project that they're on. And so we leverage Ruby on Rails heavily for our projects. We still do. And I say JavaScript. So, obviously at this time, with any major front end today, most new well-built apps that look and have a good interaction are built with some level of JavaScript in hand, utilized. At the time, we used Ember.js. And we used to do a tremendous amount of work in Ember.js. I think it's a great framework. We've moved away from it a little bit just because we think the overhead of having a fully fledged single page application built in JavaScript in front of a Ruby on Rails API, it fits some scenarios, but it also has an expense for really what you end up, the path you end up going down is you end up having a developer or developers responsible for your back end, developer or developers responsible for your front end. You end up kind of, if you want to do this well, having separate teams. We're exploring technologies today where we can not have to split the teams out as much. You definitely can do it. You can have a team of developers that are doing your front end and back end development full stack developers that are doing both. It just, with the complexity of JS today and the front end frameworks, it does become a lot of overhead. And so we've been exploring ways of being a little bit more efficient there. And actually, some of that is, just going back to server-side rendering and leveraging Ruby on Rails to do our front-end development and the back-end development and sprinkling some JS rather than relying on a full single-page application framework. So this is the prescription. Ruby on Rails API, JavaScript front-end, Postgres database. No need for 225K of licensing and support here. I'll remind you again, it's a web application, thousands of users, decent amount of data moving through the product, decent amount of touch points with third parties to get to actually send data out and receive data in for mixing it in with the data analysis that the product provided. But not putting man on the moon. This was a really good prescription for them. I'll also talk a little bit about what AWS looked like. So. Ruby on Rails API, JavaScript front end, Postgres database. How does this look in AWS? So on the AWS side, Amazon Web Services, we went with dynamically scaling app servers. In this case, we used Elastic Beanstalk. And then on the database side as well, dynamic scale DB using RDS. EBS, RDS, these are Amazon services that are available to you. RDS is basically a database as a service on the AWS side with native support for Postgres. Elastic Beanstalk is scaling app servers. There's a few different ways that you can do this. We used Elastic Beanstalk at the time. We were happy with it. Some companies that do similar work also will utilize ECS, Elastic Container Service. That's also great. I think both of these are good options. As with all things in technology, there are some pros and cons and trade-offs. But we were very happy with how this went. And so let's talk a little bit about the costs and where those ended, and a little bit about the database side. So I mentioned earlier they were giving us some early numbers of 1+ terabyte. Well, after we moved all of the data that was needed, all of the needed data for their app from the old database to the new, as part of the rebuild process, we ended up at just over 10 plus gigabytes, which was awesome. You know, I think earlier pricing models for what this was going to cost were a little bit higher just because of, you know, we thought that the data set that we were going to be storing on the AWS side would be a little bit bigger than what it was, but 10 gigabytes, that was a nice win when we went and moved all the data over. You know, when I say move, we did a ETL process where we're extracting the data from the old database, making some changes to the data so that we could load it in the new database that we had built with a new data model, a little bit more efficient and more maintainable going forward. And then combine that with the dynamic app servers and database, plus the you know, storage. We were also utilizing S3, Cloudfront. For those that aren't aware, S3 is your data storage just for not database. Think data assets, images, files, anything that you need to store that your application might use. And then Cloudfront is their CDN, so content delivery network. And so that allowed us to break out our JavaScript files, CSS files, spread them out closer to the clients who are downloading this data through their browsers for more efficiency. And so all of this, when we were done, the bill, when we finished, when we wrapped up the engagement with the company, their ongoing bill was just about $5K a month on AWS to service the product itself. And this was actually a little bit less because they had another side project that another group that was a partner of them was basically using some other services on our AWS account, which was fine. But I do remember the bill was about $5K a month. So as we close here, where were we? So global financial services company, spending lots of money to serve support on-prem servers in New York City, London, and Asia. Expensive. We went through some of those numbers earlier. 2, AWS hosted modern web application. At $5K a month, which is great. I tried to share a decent amount here, leave you with a good story. The other thing that we did as part of rebuilding the application is we did work with a designer that we have a relationship with, and he went through and rebuilt you know, the look and feel of the entire app. And so, you know, not only did they get savings, but they also got a much improved application for their clients. And you know, it's much more efficient for not only the clients to use. We had some real-time screens in there for presenting data as the data came in. So a much cleaner, much nicer interface for the clients, simpler to use, easier to find the data analysis that they were looking for, a much cheaper carrying costs for supporting this application going forward. And even, I would say, more importantly, with the product rebuild, we left them in a much better place in terms of maintaining the product going forward and putting it in a place of maintainability where it was easier to build features going forward. And you know, I mentioned earlier, you know, they had a team of 6 to 8 ops people, ops resources to support them. And actually what happened is these ops resources were re-educated with some internal training to move away from on-prem support to understanding and supporting AWS, to better use AWS and its services for future improvements to the product that we just discussed, but also some other products inside of the company that that we did not work on at the time, but that this operations team was supporting. Same thing with the development team as well. So in closing, you know, a sizable product in terms of revenue, very manageable in terms of the scale that was required, but a product that was outdated from a user interface and user experience perspective, from a technology choices, mostly just because the technologies at that point were very old, and on-prem hardware, which was a burden for the company. I don't know if I mentioned it, but one of the other issues is the office in London. They wanted to move the office in London, but that was a hard thing to do because they had a bunch of servers, and moving servers that are, you know, servicing a production system, keeping everything online, getting them into the new office, building out space in the new office for these servers. It's extremely expensive. And at the end of the day, when you start accounting for, you know, just Oracle support and licensing costs relative to a move to the cloud, it's night and day. And we didn't even discuss the retraining of assets, of resources that they had internally, building out and supporting the project previously, who could now leverage services on AWS to build out, you know, more future-proof applications, easier to use, which and leveraging more services to AWS for the future needs that they have for not only that product, but other products in their portfolio. So thank you for joining us tonight. I hope I was helpful. Please leave some comments below if there's some more stuff I could fill in here, or anything you'd like to hear about in the future. I'd love to do another video on some of those topics. Thank you again. Please hit the like button and give us some feedback. We'd love to make some more videos for you in the future. Thank you.